Hello and welcome to section 2.6, the mini lesson on proportions. We're going to cover this really quick and then hit it in more detail in class the next time we see each other. So follow along, pause if you need to, write down questions as they come up. Today we're hoping to cover these two things. You should be able to identify equivalent fractions, which are just ratios or vice versa, and solve equations using proportions, which are just fractions and ratios with an equal sign between them. So you'll see those as they come up. First, equivalent ratios. Our simplest example would be something like 2/3 and 2/3. These two are obviously equivalent because they're the same ratio. However, less obvious would be something like 4/5 and 8/10. Now, those of us who are strong with our fractions remember how to simplify fractions easily. We can see that 8 and 10 have a common factor of 2, so we can divide that top by 2, the bottom by 2, and we end up with 4/5. That means that 4/5 and 8/10 are equivalent ratios. So the simplest, most direct way we have to identify equivalent ratios is simplifying them both. However, if you're not really strong with fractions, of course, divide both of them and see if they come out to the same decimal. That works too. Now, as we're talking about what an equivalent fraction or an equivalent ratio is, we also have to look at what one isn't, and for an example we can look at 2/5 and 7/14. Now these don't look to be equivalent, but we need to check, and the way I would approach it is I'd simplify. 2/5 is already simplified, but 7/14, divide the top by 7, divide the bottom by 7, we get 1/2. 2/5 and 1/2 are not equivalent, and so therefore we know this is not an example of equivalent ratios. Again, if you're not strong with simplifying fractions, there is no shame in pulling out a calculator, top divided by bottom. I'd rather you be sure than do it the way I like it. Pause and take notes if you need to. This is a proportion. It's a ratio equaling another ratio. However, we don't know one of the values, and so we're going to have to solve it. And the way we're going to solve it is called cross multiplying, which is really just multiplying both sides by a denominator, but cross multiplying rings a lot of positive bells for people, so we'll stick with that name. Now, what we're going to do is we're going to take the denominator of one side, in this case we'll start with the 5, and multiply it by the numerator of the other side, the x. 5 times x is just 5x. On the opposite side of the equation, we have the opposite denominator, the 10, multiplied by 3. So we end up with 3 times 10. I put them in numerical order. You could do 10 times 3 and you'll get the same result. Now, with that all done, now instead of having two fractions to deal with, we just have 5x equals 3 times 10. It should be simple at this point to just solve the equation. So multiply the 3 and the 10, you get 5x equals 30. Divide both sides by 5 so we can get rid of the 5, and ultimately we're left with x equals 6. And that, ladies and gentlemen, is what we are doing in this section. We are going to identify equivalent ratios or equivalent fractions, and then we're going to solve proportions where there's an x in one fraction, there's not an x in another fraction, they're equal to each other, and we have to use cross multiplying to solve them both. Okay, we'll talk in class about how we can also use cross multiplying to identify equivalency, but for right now we've got our simple simplifying, we've got our simple calculator, and we have our relatively simple cross multiplying. All these things we'll practice more the next time we see each other. For now, take your notes down, complete the brain genie activity, and bring your questions to class tomorrow. Looking forward to it. Thank you.